Imagine a dragonfly with a wingspan reaching nearly a meter, patrolling the skies directly above you. It is no creature of fiction, no monster from a horror film, but a genuine inhabitant of our world. And the coal beneath your feet? It is the fossilized remnant of the very empire they once called home. 300 million years ago, the true masters of Earth were not the dinosaurs, but a caste of creatures that, today, belong only in our fever dreams. This epoch is known as the Carboniferous, a cold geologic label, yet it bestowed upon us our most potent legacy: coal. Back then, vast swamp forests cloaked the continents. As these primitive trees died, they were buried rapidly, locking their carbon away deep beneath the earth. Multiple studies and climate models suggest that atmospheric oxygen during this time soared to 30 or even 35%, a stark contrast to the 21% we breathe today. This surplus of oxygen did not make the world gentler. Instead, it transformed our planet into a biological forge for monsters. Picture this landscape: swamplands stretching toward an endless horizon, where the air hangs thick, damp, and heavy. Giant ferns rise like emerald monoliths, towering over the earth. The thrum of insect wings carries the weight of a low-altitude storm. There is no birdsong here, no soft footfalls of mammals. This is a kingdom of chitin and segment, a planet being quietly reshaped by the very air that envelops it. The way insects breathe is fundamentally alien to our own experience. They possess no lungs. Instead, oxygen enters through microscopic pores called spiracles, traveling along a labyrinth of tubes, a tracheal network that delivers life directly to every cell. This system is a marvel of efficiency, yet it carries an inescapable physical ceiling. As a creature grows, its demand for oxygen increases by its volume, its cubic mass. But the efficiency of these delivery tubes only increases by its surface area. In today's air, this constraint anchors insects to a miniature world. But in the Carboniferous, the air was thicker, saturated. Oxygen diffused deeper, and the boundaries of possibility were pushed back. And so, their size spiraled out of control. What if we were to step into that ancient atmosphere? At first, you would feel an extraordinary surge of vitality. Breathing would be effortless. Your muscles would recover with a startling, almost superhuman speed. But this euphoric high would be short-lived. The sheer abundance of oxygen would begin to ravage your cells through oxidative stress. Your lungs and your nervous system would struggle to cope with the immense and lethal pressure. What was a paradise for the insect would be a toxic furnace for us. It is a stark reminder that the Earth offers no perfect environment. There are only the specific conditions that allow certain forms of life to thrive. In the skies above, there emerged the Meganeura. With a wingspan exceeding 60 centimeters, it rivaled the size of a modern bird of prey. And the dragonfly was then, as it is now, one of nature's most lethal aerial assassins. But crucially, they held a monopoly on the heavens. There were no birds, no pterosaurs, no lung-breathing vertebrates of any kind to challenge their reign. Meanwhile, on the forest floor, moved a segmented titan, Arthropleura. Growing to lengths of over 2.5 meters, it was a millipede, magnified 100-fold. A creature so monumental that if you were to stand beside it, its head would be level with your waist. Intriguingly, our understanding of what Arthropleura actually consumed is undergoing a profound shift. For decades, it was portrayed as a fearsome apex predator, a nightmare stalking the undergrowth. But recent analysis of its fossilized gut contents tells a different story. They suggest a diet of decaying plant matter. In other words, it was no killing machine. Instead, it was the Carboniferous forest's giant bulldozer. But this empire held a fatal Achilles heel. Its entire sovereignty was built upon the very air itself. As the Carboniferous drew to a close, the world began to change. Vegetation shifted, volcanic fury surged, and the planet's carbon cycle was violently rewritten. Atmospheric oxygen began its long, slow retreat. For the miniature insect, this was merely a struggle. But for the titans, size was no longer a gift. The larger the body, the higher the metabolic demand, and their primitive tracheal systems were pushed to the absolute brink. What was once their greatest strength had become their ultimate liability. Beyond the respiratory system, insects faced a second, insurmountable ceiling. Their bodies are encased in an exoskeleton. The larger the creature, the thicker and heavier this external armor must become. Every act of molting, shedding the old shell to grow, becomes a perilous gamble between life and death. In those vulnerable moments, a giant's own weight could crush its soft, unhardened body. At a certain scale, the exoskeleton ceases to be a shield. It becomes a burden, an inescapable prison that they simply cannot carry. The receding tide of oxygen did more than just diminish the insect. It subtly realigned the balance of power on land. Vertebrates, lung-bearers with internal scaffolds, began to seize a profound advantage. Their biology was better suited to this leaner, thinner air. This was a dispassionate ecological displacement. There were no grand battles, no heroic last stands, only the cold mathematics of survival in a shifting world. The age of the giant insect had reached its conclusion. The era of the vertebrate was only just beginning. The ultimate revelation left by the empire of giant insects is this: the scale of our world is not dictated by tooth or claw, but by the very air that sustains us. Today, as we burn coal, oil, and gas, we are, in essence, rewriting this planet's atmospheric ledger. Scientific observations reveal that modern oxygen levels are falling. It is a decline that is slow, yet undeniably real. 300 million years ago, the air summoned these monsters into being, and the air dismissed them. We are but a transient moment in a world governed by rules far older than ourselves.